position in the activation layer, right? So now is V a vector or not?
Yeah, V is a vector. So Vi is the index in the activation output.
Okay.
So that is not a vector, that is a number. Yeah. And then well they put that one, they put it at 0 just to put it somewhere.
And the sum over I looks like the sum, because I is between 1 and alpha, so I is now a class label.
Yeah, no, this is not a class label. This is the output here. So if you have the output here,
but above it is for I equals 1 to alpha.
Where it is?
Line 2.
No, from I to alpha. Alpha is the number of top classes that you want to see. So you're sorting the classes by activation, and then you're picking the top alpha, and then you are
two different I's, yeah.
Yeah, they're different. So if you picked only, if we say that is the top 1 and that one is the top 2, in the end you're going to multiply this by a weight here. So W1 of x and that one by Wn of x. And that one is going to be multiplied by 1. Yeah? So you're revising the activations?
Actually by 0.
No, by 1.
Oh yeah.
By 1. So you let it, you leave them the same.
On the V hat, V0 hat.
Yeah, V0 hat is
so
the pseudo activation. They call it pseudo activation because it doesn't come from the example, but it comes from the remaining probability. So they say, well, if you have the probabilities for all these, all the remaining probability has to be assigned to that one. So here they assign V0 of x. Yeah.
So what happens with all the neurons below, or neurons after?
After what?
After?
No. So it's you find what are the top activations.
Yeah. But then what do you do with the rest?
You just let them to 1.
Ah, yeah, 1.
Yeah.
One question.
So you don't make them 1. You multiply them by 1 here. This is the top part.
You keep them as they are.
Yeah. So times.
Carlos.
Yeah.
I have one question.
Yeah.
Isn't the W incorrect? Shouldn't it be 1 minus that quantity? Because that quantity looks like for if you're very far from tau, which is the mean of the class, then that is going to be 1, and that should be 0.
Tau is not, x is the distance from the mean, and tau is a shifting parameter that comes from fitting the distribution.
Okay.
So they remove weight from the
this
top,
x.
put at the bottom with the top alphas to put the extra class. So they remove a little bit of weight from each top alpha.
No, it's about
that.
No. Here x is the distance from the mean.
Yeah, but if x is big, that omega becomes 1. If x is let's say
x is 0, that becomes 1. So the probability of it being in the class is 1. So it remains the same.
It would be if x, like let's say tau is 0. If x is 0, then e to the power of 0 becomes 1, and then omega becomes 0, or like almost 0. While if x goes to infinity,
then omega becomes 1, right?
No.
Oh, that becomes 1.
E to the 0 is 1.
Yeah, so shouldn't it be like 1 minus that quantity, and then like shouldn't the adjustment be V hat equals Vx times 1 minus omega, and then V0 be multiplied by omega?
No, I don't think so.
Think of x very big, so a clear outlier, then the e to the power minus something becomes almost 0, so omega is 1, and so there's no adjustment, but there should be a lot of adjustment.
This becomes 1, so it's a large outlier.
And then when you do the revision activation vector, is the same as it was before.
Yeah.
Like.
Yeah, or tau is the mean then. Possibly. It's not clear. It's true that
it
it's
would
not
be
clear.
kind of the same though. Like I think it just is a typo. It shouldn't be. They should switch omega and 1 minus omega in line 5 and 6.
Okay.
Maybe x is not the distance. X because you have bx, right? So
yeah, no, they do say that x is the. So they calculate that.
You have to swap omega and 1 minus omega.
Yeah. So we use Weibull CDF probability on the distance between x and mu I for the core of the rejection estimation. So that x is the distance between the vector and the mean.
Yeah, but like if something is an outlier, the probability that the white Boult distribution is smaller than the outlier is like 1.
Yeah.
So that all the thing becomes small. All the thing becomes
V0 should be high and the
yeah.
SI should be low.
Yeah.
So you should swap and you got -1 minus something.
Basically, rather than using the CDF, they should use the survival function.
Yeah. Okay. Well. Okay.
I'm still confused. So this V0 is now a number or a vector, right? Because it feels like we're trying to build a vector that is as furthest away from all the other activations.
V0 is a number.
So V0 is a number. V0 is just the remain. So if these are all the probabilities. So this is the mean activation vector.
But the activation is not necessarily probability, right?
But they treat them as probabilities. That's what softmax does, right? Softmax normalizes everything, so that it's going to be treated as a probability. So what they do here is so this trick, what does is when you normalize, it adds to 1. Yeah?
I see.
So it adds to 1 and then you treat them as probabilities. Okay? So say for that confusion, which we would have to double and triple check. So you do your activation, you normalize as in softmax, and then you find, same as in softmax, you find which is the biggest activation. If the biggest activation is the rejection class, then you reject. You say this is an outlier of all the classes. However, if they argue that you still cannot neglect the uncertainty estimate, so they also set the threshold that we talked about before. So they have both conditions. So if all of the activations are less than epsilon, then you say, in any case, the network is not sure of the output. Yes?
But then the configuration is expressed in Boolean logic. The configuration of an unknown has to reach a Boolean conclusion.
Well, yes, yeah. So here's what they say. Well, you mean that it's either classified or not classified?
Yes.
If it is not classified, they leave that as an open question. So what to do with a with what was not class with what was decided as unknown? They don't provide like what to do with that. They just say this helps you recognize it.
But then, sorry, there is no classification of a non-classification.
Yeah. So y asterisk is your classification output. So it's going to be the maximum probability. So that can be either 0, 1, 2, 3, 4, 5, or n. Okay. So if it's 1 to n, you provide the classification output. So you say my classification was class 2, class 3, class 1. If it's the 0 class, you say my classification is I don't know.
But
And then what to do with that?
Sorry, but then what I'm trying to figure out is that is still expressed in Boolean logic as a 0, the unknown is returned false.
The unknown becomes a classification class.
Right.
So it becomes a classification output. So your softmax is going to have a distribution here. And, well, no, your OpenMax is going to have a distribution here. Each class is going to have, this is going to be a number. So it's going to be 0.1, 0.2, 0.3, and then